Hello, welcome to Sigma Made Simple. This channel is dedicated to explaining the principles of Lean Sigma and Six Sigma to anyone with little or no knowledge who wish to learn some basic principles to make improvements. My name is Dennis Ray Wells, and I was learning about these tools even before I was certified in 2008 as a Six Sigma Black Belt and Lean Sigma Green Belt in 2009. This video shows a process anyone can use to document the project, its goals, and what was done to complete it. Write this document as if you will not be around in the future, but someone in the future will want to know what you did, how you did it, and why you did it. This will help your team stay focused on the same ideas and criteria. At the top of the project charter, you can put the project number and the project name. If you have a spreadsheet like an EIC spreadsheet, you should put a link to this project charter in that spreadsheet so that people can get at it easily. Should also save the file save the file with the name of the project number and the project name as the file name so that you can easily find it later. You can put your name in the author and then put the date. And the date that is in here is the date that you started this project or that you started filling this out. Then you need to define your team. Who is it? Team members, what their role is on the team, and then the percentage of time that they might be needed, and put their manager in here. Always verify with their manager that you can have that person for that period of time. These are just some examples, but it could be a very lengthy team list. All of this is part of the define phase. The define phase is going to be updated as you go through measure, analyze, and improve phases. I'm going to go through the other criteria. So one of the things that you'll want to do is define your scope. What product family you're going to use, what processes, the area you're going to concentrate on, anything like that. Put that in here to keep your team focused. You also want to note anything that you do not want to include in the project or something you don't want to impact. Basically anything, if you're going to be working in an area where there's many workstations or many products going on, but you want to concentrate on one product family, that's what you would capture here. Then you want to come up with a problem statement. Initially, you probably are not going to have a lot of data. You're going to have some intuition, and that's fine. You'll be verifying the problem statement as well as goals when you get to the measure and analyze phase. But you should have some numbers. It should be really short, and it should be like what they call it, like an elevator conversation. One example would be the yield at Station 1 is 80%, causing 855,000 US dollars in rework per year. That's a pretty decent problem statement, and you'll update that when you go through measure and analyze. The goals are very similar, so what do we want to do? We should have some numbers in here. You could have some, for example, related to the above, increase the yield at Station 1 to 90% or more, saving $427,000 US dollars in rework costs per year. You should also put down in here what metric you're going to use. And here we're going to say our key process output variable, KPOV, is going to be visual inspection. We're going to concentrate on the visual inspection from Station 1. And then we'll put what type of chart will be used to track the metric. So the type of chart you use will probably be suggested by a black belt, Six Sigma black belt, or a Lean Sigma green belt. There are many different types of control charts out there. You may not know what that is now, and that's fine. You can leave that blank, come back to it later, or you can remove it because we will define it later. Then there's a cost benefit or business case. And basically what you're doing is you're saying, this is the benefit that we're going to experience, and these are the costs. This is our justification or a business case. We're going to increase Station 1 yield from 80 to 90% or more, savings $427,000 per year. Then you're going to have a summary results section. Now, the reason why we have these 5 sections first is so that somebody like a manager or someone in the future can get an idea of what your problem statement was, your goals, and then look at the summary results. Did this work or not? The other thing about summary results is you can put in here why you did not move forward. So if you're going to evaluate a piece of equipment and you're going to see if it does perform better than your existing equipment, and you find that it doesn't, you can put that in the summary results. So when management turns over, you can, and then the new manager comes in and has basically the same idea as the previous manager or somebody in the past, you can give them this document and say, yeah, we looked at that equipment and we found it wasn't performing, and it wasn't performing because it wouldn't pass gauge R&R, and our current equipment does, so we couldn't use it. So it'll save you a lot of time in the future. Next is your counterbalance. It's very important to have a counterbalance. What metric was used? In this case, for an example, we're going to say, well, we're going to increase the yield at station 1, but our counterbalances do not decrease the yield at stations 3 or 4. Those are other inspection points that come about as a result of station 1. You also do not want to increase the cost of materials or labor to exceed the savings. Doesn't do you any good to save $427,000 a year if you're going to double the time and it's going to cost you $800,000 a year to do that. It's an old saying from Six Sigma that I've developed, and that is, don't create a monster bigger than the one you're trying to slay. You may also have a counterbalance in there, like do not affect the performance of another product that's maybe running in the same area, on the same line, or shares a process. You can put in here what type of chart you're going to be used to track that metric to make sure that you're not impacting that metric in the future. You may decide that you don't want to track that metric in the future. You're just going to test it. That's fine. That will come later. If no chart can be used for the counterbalance, will not be impacted. If no chart can be used, how will you ensure the counterbalance will not be impacted? So one example would be if you've got a process that's shared between product A and B, you're concentrating on product A, maybe the changes that improve product A's performance negatively affected B. So you said, well, we're going to make another process, a separate process for A and a separate process for B, so that B can maintain its performance. And we're not going to include B in this project because up above, where we scoped our project, it said that we weren't going to deal with product B yet. Doesn't mean you can't do it in the future. So measure and analyze. This is your test plan, basically. And what you want to do is document your current state, and that's like the measure phase in the DMAIC process. You should include current operator technician facing documents, outline the processes followed. If you don't have current processes, you should find out what's going on and document them. You don't necessarily have to do that. You could document it here for now. Just work with management, people on the floor, operations. Write down, what are we doing now that we want to improve? Then we're going to get into the measure and analyze phase. And what you're going to do is you're going to evaluate how well you're performing now, and you're going to use statistical tools. And you might be comparing it to other ideas, like I want to try a different material. And then you'll do any type of test. So there are a lot of tests listed here, and you may not use them all. You might use different ones. These are just some suggestions. Remove the ones that you don't want to use, add the ones that you are using, but you should put in here, for example, if you wanted to do an ANOVA, and you're going to use 2 different materials, but you're going to use the same process. You could run a set of data with one material A, another set with material B, and then look, and you're going to use ANOVA to see if the output of the process was statistically significant and if there was an improvement when you used product B. So this is just kind of noting what tools you used, how you used them, what the results were. Now, it's very important to also document your data collection method. You want to note down your KPIVs, KPOVs, key process input variables, key process output variables, how you collected the data, what part numbers you used, what equipment you used, um, possibly the serial number of the equipment, um, those types of things, and how you collected it. And it doesn't hurt to do a little risk analysis here so you can avoid a type 1 or 2 error. Then when you're done comparing the um, the ideas from the current process that might improve and to create the proposed process, you'll want to capture those hypothesis test results. You always want to use you always want to look at a 95% confidence level for looking for improvements. So just document in here, these are the results. That gets you into the improve phase, and that's where you're going to have the proposed or future state. Basically, you're going to detail what you changed. You're going to tell them what revision of the documents is the new revision. Um, if you had to separate documents, you'll note that here. Say when we made the improvement for product A, the process was not. It actually made our product B worse, so we decided to break it off. It's going to have its own process until we can develop something for B. Should also be aware of any cost changes. Make sure that you're going to support your counterbalances and your goals. If there's a change at this point, you should go back up to the top and correct the first sections where you have the numbers for your problem statement, your goals, counterbalances, and your business case. And then the last phase is your control phase. And this is probably one of the most important if you want to maintain the changes that you've made and the improvements that you've made. Controls are used to ensure the actions taken stay in place. You'll describe the control chart, why it was selected, what the criteria for use is, how often are you going to use it, how is the data for the control chart collected. You want to be very specific on that. You don't want to have different data collection methods coming and going because that'll increase your standard deviation and make it more difficult to detect change. Who does the data collection? Who or how the control chart is reviewed, and for special cause, what happens if special cause exists, what document controls this process, and who is trained on that. And that's basically a good template for documenting what you want to do with a project. Later videos, we're going to have some specific examples. I think the next video is going to have something specific for 5S. That was based off of some experience that I had in the past. There's also, I went through the whole project charter here. In the next video, it's going to show you how to take a project idea or opportunity from the EIC matrix and take it from intuition to active. And then the next video I think will be from active to inactive or completion. And then after that, I'll do a couple more videos for different types of projects, just so you get a feel for how this project charter is set up so that you don't have to do everything that is in there, but you should at least consider the things that are in there. So if you found this video useful, like it, subscribe to the channel, and share it with anyone else who may find it useful. If you didn't find this video useful, then subscribe in the hopes that an upcoming video will be useful. Thank you. We'll see you in the next video.